Hey everyone, welcome to the stream. It's Alfred.
Submarine.
This is episode 141, and in this episode, we're going to be interviewing David Tischler. He's the CEO and founder of miniNodes. Without further ado, let's pass it over to David.
Awesome. Hey David, how you doing?
Awesome. Hey, good morning, guys. Thanks for having me.
Morning.
Hey, yeah, thanks for coming on.
Yeah.
Afternoon for us now.
I actually just realized, wait a minute, I said good morning. It's morning here, but you are no longer morning.
Close enough.
But there's people all over probably it's the thing about YouTube is it's global. It's morning somewhere,
Right.
night
Yeah,
somewhere.
it's morning somewhere.
Yeah, about half the world or something. Cool.
Awesome.
So thanks for coming on. Really appreciate it. We've met you a couple times at ARM TechCon, at not at the Bay Area Maker Faire, but at ARM TechCon once or twice.
We also saw
Yeah.
twice.
Yeah.
Arm TechCon last year and then this year.
Mm-hmm.
Innovator Summit, you guys were there, right?
Yeah, our CEO was there.
Yeah, the Alpha was there. We're trying to think. Yeah, we cross over a lot of events as fellow innovators.
Yeah.
And you guys are going to be at the upcoming
AIoT.
ARM AIoT event.
Yeah.
Most
I
likely,
can't.
yes.
Yeah, I can't make that one due to conflict of dates. But my colleague Carl from Packet is going to be there presenting our project we built this year for the Innovator Program, and we'll talk about that in a few minutes.
Ooh, yeah, I would love to.
Yeah.
So why don't you start by telling us all about miniNodes and just your journey with miniNodes?
Yeah, definitely. So it's been a couple of years now. I think it's been about 5 or 6 that I've been doing this. But I actually started out my career working for a big hosting and domain name and email provider here in the United States called GoDaddy. So any international viewers, I don't know how familiar you are, but here in the US, they're a big provider. And so domain names and email and those types of services are not a huge deal from a server perspective, but also part of the product lineup that I was responsible for there was the VPS, which is virtual private server, and bare metal dedicated hosting boxes. So from a support perspective, as customers would send in tickets that say, hey, my server's broken, or hey, I can't access this, or I'm having trouble doing whatever it is they wanted to do on their servers. Every time I would log into these customer machines, I would notice that they're idle 99% of the day. Okay, so that starts me thinking, these customers are paying a lot of money for a very high power server that is just sitting in the rack doing nothing for a vast portion of the day. So there's just racks and racks of wasted compute, wasted power, wasted electricity over and over again. And so I started to then think about, is there a market for smaller servers?
Right.
Are there other options out there that are lower power that would make more sense for some people? Certainly not everybody. There are people doing deep learning. There are people doing data science, data analysis. Yes, they need the biggest, fastest Xeon or AMD EPYC they can buy. I totally get that. But, there's another segment of the market out there where smaller servers are just fine.
Yeah.
So that got me kind of thinking about, these smaller footprint, like can a Raspberry Pi or similar device like a 96 boards single board computer actually function as a server? And so that's kind of where it all started from.
Yeah, that makes a lot of sense. I feel like for a lot of people, especially if you're hosting a website or something, it's probably not that process intensive. You don't need a beefy server, but you're just going to go on GoDaddy and buy, however much. So that makes a lot of sense because you don't think about that as somebody who just wants to host a website. You don't think about, oh, there's going to be useless power like consumption.
Yeah.
Like
Yeah.
you know, like it's
Yeah.
not the first thing on your mind, so you wouldn't even think about it unless you have an alternative out there for you.
Right, exactly. No, customers definitely didn't consider that. And you know, they obviously they actually really didn't need to consider it because it's not their server in the first place. So, you know, it wasn't necessarily part of the thought process, but I think that's where perhaps like, from an mental standpoint kind of felt like, well, I can perhaps change people's mind and, you know, kind of teach them that, you know, there's a carbon footprint to this, and let's see what we can do to minimize that impact.
Yeah. So how does miniNodes play into this? What have you guys done in order to mitigate this or reduce the carbon footprint?
Yeah, so, you know, kind of like we were mentioning then, there are just a few niche markets that we really go after, that we excel in. Because, like I mentioned, there are people out there that absolutely need the biggest, fastest server that they can buy, and I get that. But there are also people that are looking for cheap, bare metal servers. So that's one market where miniNodes operates in, and I'll come back around to the environmental and carbon footprint in a moment. There are people that are looking for Raspberry Pi or other ARM specific devices. They just are truly seeking an alternative, typically when testing code. They're looking for an ARM server just because it's an ARM server. And then there are, you know, people that, kind of like we said, are really looking for minimum or modest amount of compute. And those are the ones that, you know, maybe they are a bit more environmentally conscious, or they are just simply looking to reduce their footprint, you know, in any way that they can. And so, no, I don't specifically measure the wattage at the wall or at the board level, but it is definitely a fair assumption to say that a Raspberry Pi, a 96 boards or similar, draw significantly less wattage than, you know, a two-way Xeon with dual 800 or 1600 watt power supplies. So, you know, there are people that are making conscious decision.
Okay. So your market is essentially environmentally conscious developers, kind of.
Well, several different markets, like
Yes.
sort of as I just discussed. But yeah,
Yes.
that is certainly one of them.
Okay.
Okay.
That's interesting. So,
Mhm.
how have you kind of reached your market? You know, how have you been able to seek out those types of people?
Well, you know, here's a good opportunity to plug the ARM Innovator Program, right? You know, the Innovator Program certainly gives me a platform to broadcast upon. I know that Robert from ARM is on the live stream, and he runs a community that is specifically devoted to ARM developers. So I participate in there. Of course, social media obviously helps. That's a given. But, you know, essentially just participation in industry events, and social media, and being active in the community is how you get the word out.
That's true. I mean, organic word of
Yep.
mouth goes a long way too. Just people
Yep.
who are maybe using it, going like, "Hey, this is a cool way you can use
Mhm.
mini servers to reduce carbon footprint." Probably does a lot as well.
Yep, absolutely. So, you know, there's enthusiasts out there that are, like I said, seeking out this particular product. And so that they find up good old fashioned Google also works.
Yeah.
And so, talking about Robert, back at last year's ARM TechCon, you and Robert had this really cool, like, solar development box with like 96 boards in it. Could you talk a little bit about that and how that came to be?
Yeah, definitely. So that actually then leads into what I'll talk about, which is this year's project as well for the ARM Innovator Program. So last year's project, that solar developer box, that was all Robert. That was he was the inventor and creator of that, and I just wanted to tag along, just to be able to attend TechCon. But yeah, he put together an amazing hit, and talk about innovation, right? Like, and how far these single board computers have actually. So he built out a solar powered mobile computing platform. So in like a repurposed, looks like a briefcase, but it's the intended use originally more like a toolbox or carrying case. And in it he put battery, inverter, charge controller, and a 96 boards device with a small LCD output, HDMI output to an LCD. And then we attached a mezzanine that had a 4G LTE cellular SIM card on it, and ran the whole thing off of solar panels. And it doesn't draw that much wattage, really, So it was using, I want to say, a Qualcomm Dragon board. And that Dragon board was then able to also share its 4G LTE connection out over a Ethernet connection to a secondary device, which is a Raspberry Pi compute module that was running, at the time, I think it's actually still called this, the Azure IoT Edge, which allows you to put containers remotely. So you had this completely self-contained device that could be tossed out into the wilderness and could be interacted with remotely for pushing workloads from a central location, or if you're out in the field, it has a keyboard, a mouse, and a monitor. You can literally compute anywhere. So it's a industrial strength, rugged laptop at that point. Yeah, it was incredible. The amount of work he put into it. He even got a Rev V.2 underway as well. Cool. So anyone that has questions on that can reach out to him. We can get you his contact info, no problem.
Awesome.
This year, for our Innovate project, I sort of transitioned from that into a more thorough infrastructure of IoT to the edge to the cloud, all running on ARM. I had seen a lot of conversations, social media, keynote speeches, just everywhere, everybody talking about the edge, the IoT to the cloud over and over. And I kept looking for examples, like somebody to show me one of these in practice, and nobody had actually gone out and done the work and built it. So there might be some internal, projects at companies that have sort of tackled that, but they're just not like publicly available. Mm-hmm. So with Carl from the Works on ARM program, that's run by Packet, he and I put together a complete infrastructure. So we took Raspberry Pis, attached some weather sensors, and distributed them around the globe. They feed the data from those sensors up to a geographically located edge device. The edge device is a 96 boards device. So also, based on ARM processor, obviously. The edge gateway takes the incoming sensor data from the IoT endpoints and translates it into InfluxDB, and then pushes that up to a big enterprise-grade ARM server that's hosted by Packet. So you've got all three layers accounted for, totally end-to-end, running on ARM. And we showed that off at Lenaro Connect and at ARM TechCon. I gave a talk about it there. With a live demo, it's got a Grafana dashboard. You can drill into the data. Like, it's the whole complete solution. It's obviously a very simple demonstration. It's a proof of concept. I mean, we're just charting temperature and humidity from around the world. Like, that's not exactly rocket science, but the premise is that it works. The data is flowing from IoT to edge to cloud, all on ARM.
Yeah.
So
that's really interesting. I think most people tend to think of edge and cloud as like opposites or like mutually exclusive, basically.
Yeah.
But they do go kind of hand in hand, because edge just means you're processing on device. Yeah. And that is like a spectrum. You can process like a lot all on the device or some on the device in any extent. And then the rest can be cloud. So like they go hand in hand. So I think that's a great way to showcase that IoT and edge are not polar opposites. You can have both in varying degrees. Yeah, that's interesting.
Mm-hmm. Yeah, you know, we've seen these trends in the media, but I hadn't actually seen a functional example of it. So that was the the goal of building it out. And like I say, the innovator program helped fund that project and provide resources for it. So it was awesome.
Yeah. Awesome. I remember we were at Voice Summit and somebody came up to us and was like, "What exactly is edge?" Because I hear these
well, the definition, it depends on who you're asking.
Exactly.
That's true.
It's true. It's hard because they're thrown around so easily. It's really hard to know what somebody means when they're saying edge. But yeah, I think like having a demo that very clearly shows like the intermingling is more helpful for people to be on the same page about what we're thinking about when we talk about it.
Yeah, kind of touching on that point about what is the edge, and that depends on, who you're talking to. But I like to think of it as this trend where the past decade, or maybe even more than a decade, has been all about the cloud. Push it to the cloud. Put your servers in the cloud. Put your storage in the cloud. Yeah. Everything, get it out of here. It's cheaper, it's faster, it's more reliable in the cloud. So that's all well and good, but I think we're seeing this trend now where, the cloud is not the best option for literally everything. Running services locally, running services closer to the end user or the customer is becoming more of a viable option with these smaller form factor devices. I mean, literally, like the Matrix is a perfect example, right? Like, not everything needs to go to the cloud. Running some workloads at the edge, and you can define edge as you see fit, but that is becoming a more viable solution in a lot of cases. Small form factor devices, quite a bit of processing power on device, perhaps unreliable power and connectivity in remote locations. Like, there's all kinds of things out there. It does not make sense to put it in the cloud.
Yeah. And when you're getting even more complicated deployments, like self-driving cars is an easy one. Like if you are in the middle of nowhere, you still want your car to drive itself.
Yeah, exactly.
So you need all that processing happening locally.
You see Tesla, showing off their SoC, like 16 core or 24 core or something.
Yeah, it's a custom ASIC.
Yeah, they're custom. Yeah, so, but yeah, like the car still needs to drive, so whether you have connectivity or not. So yeah, it's interesting, that these, the sheer amount of compute in a small form factor with a lower, a low thermal footprint, it's totally crazy what you can do.
Yeah, it's only increasing.
It's
amazing. Moore's Law.
Yep. So,
let me see what other questions we had
here.
Well, one of them was, and liked your answers that you wrote. Like I thought your answer was interesting. But if microservers or like more like device-based servers pose higher security risks, and you had keep going. What you said.
Yeah, you had asked me about are there any security implications of microservers, and I thought not from a computing perspective, because whether a server is small, medium, or large, it is essentially doing the same thing. So you need to have proper access control, user authorization, safety like firewalls and, segmented networks and all of the standard things that one would associate with server hardening and server security. But what does change is the physical proximity of the server. So if you are doing computing in a vehicle, okay, it's probably hard to access if the CPU is, and or storage is somewhere in the middle of the vehicle that you have to take apart the dashboard and, get at. It would take multiple hours. Your attack vector is small there. But if it's an IoT device and you literally go leave it out in the wilderness, who's to stop anyone from stumbling upon it and saying, wow, that looks really cool. I think I'll take it home. That's, so there's different security, things to think about depending upon where the device is located. Let's say it's at the base of a cell phone tower and you're placing a server in there. You may have contractors that go in and out. Sometimes the cell phone towers are placed upon electrical towers. Then you have like an entirely different organization. You have the electric company that has access to it. So you kind of have to think through these other facets of securing the device, like physical security as well. If a server's in a data center, like it's a safe assumption. I mean, certainly anything can happen, but it is a fairly safe assumption that the device is secured and locked down and has access control. But if the device is, just on top of a building, any maintenance worker with ease has access. So you got to be a little more careful about that.
Yeah.
I mean, I've even seen like in a movie theater, like a Raspberry Pi behind a screen running the screen, and so that's I could have easily like plugged in a USB into it and changed what was on the screen.
Yeah,
absolutely. Yeah, the
easy.
physical attack vector is something that you need to be more aware of.
Yeah, it's interesting. Like I remember at ARM-TechCon this year, at the ARM booth, there was one of the ARM people who is completely cybersecurity had a demo where you can open a chip, put a little thing in there, and I was like, isn't that hard? He was like, no, it's easy. Like anybody can do it. It's really easy to open the chip and put this in there. And I was like, oh, and
open physically, opening a chip?
Open the chip, put a little thing in there.
What?
I mean, and it just like can decrypt anything like really fast. And that's what he was showing. He was showing a security vulnerability, and that's his job. His job is to find physical security vulnerabilities and then figure out how to protect against them.
Wow.
And
that was
crazy. That was crazy. So like when I saw your answer saying like the physical thing, it reminded me of like that, and I'm like, yeah, that's true. There's so many different ways physical security can be threatened.
Yeah.
So,
yeah. I mean, a firewall or disabling unused services or network segmentation is all well and good, but if somebody's got physical access to the device, forget it. Game over.
Yeah. So that was definitely an interesting thing to consider.
Huh, interesting. Wow. I can't believe I didn't check that booth out.
Yeah, it was in this. We were in the ARM booth as well, so it was just around us.
Yeah. Okay. So let's see. We covered edge computing.
So the other question that I'm not sure if you have an answer yet is like if you've seen any interesting or cool applications of miniNodes around the world. Yeah.
Yeah, I forgot to jot down an answer for you. I apologize.
Oh no, I was just wondering if you like can think of anything.
So because again, kind of like we talked about, it's pretty niche, right? Like I get that, security researchers from I want to say University of Michigan used miniNodes when doing a doctoral thesis. So I've seen that. I've seen people, the original Docker team used miniNodes. Like this is way back in the day when it was really, really hard to get ARM servers. They did some engineering work, a lot of kernel developers. I'm trying to think of some others.
Mitch is right. Kernel developer.
Yeah. A company that starts with an F and ends with an Ace book has done some deep learning experimentation on them. There've been quite a few interesting ones that have come through. I apologize, I didn't think of some in advance.
Oh no. Like I was just curious if you had thought of any since writing the answer. So
yeah.
Well, here's the thing I just thought of. You guys host the ARM servers yourselves, right?
Yeah.
So how do you go about doing that? Like, do you have like a huge warehouse? Like, what is this? I can't imagine hosting so many servers.
Yeah, so it's less scientific than I would like it to be. But actually, perhaps this is a good time to plug my most recent blog post, which let me grab
in the description.
What's that?
Oh, we can link it in the description.
Yeah, /blog. So miniNodes.com/blog, and then it's the most recent one, which is hosted Raspberry Pi 4 servers coming soon.
That one. Yeah.
So it's difficult to host single board computers in bulk because they lack the management of a more traditional server like BMCs or dual Ethernet connections to be able to have a private LAN and a public LAN. So this post right here on the Pi 4 is a good one in that what we have to do is go through this process of building out a internal control mechanism or management plane that allows us to provision automatically and also allows customer SSH or console access to a device if it gets knocked offline somehow. So then, and you can see in this post that, if you guys could drop the link in afterwards would be cool. You can see then we have to tackle thermal challenges. So like how much air is flowing through a 1U or a 2U chassis. Pi 4s, for example, are better now as of a few days ago, but notoriously ran pretty hot for the past few months. So it's actually quite an undertaking. And it's not all built out. A lot of it is still manual. So, it's not ideal, but it's doable.
Okay, cool.
Yeah,
nice.
That's interesting.
Yeah.
Yeah, I mean, it seems
duct tape and glue.
Yeah. Oh, yeah, we have a lot of that.
Yeah.
Yep.
My favorite thing, or not my favorite, but like something we have to do a lot. I've had to do a lot in my life is software duct tape. Like a lot. A lot of if this happens, please don't do this.
Yeah.
And especially in robotics projects.
Oh,
just
don't let it kill itself.
Every edge case that I can think of, just have a bunch of software duct tape in there.
Yeah.
Yeah.
So do you have any recommendations for like tools, tutorials, just resources that like a new developer that wants to get into like making servers or developing on them could use?
So this is sort of a combination of answer of like getting started for a enthusiast or a home hacker or maker, as well as then the transition into learning about servers or server administration. But no matter what, you cannot beat the price and capability of a Raspberry Pi Zero. And I say that one specifically because it's only $5 US. I know that some, from a global audience perspective, some of the single board computers actually get fairly expensive. You get what you pay for, and the capability and specifications of those more expensive devices certainly warrant the increased price tag. But literally to get started is a $5 price point. That is the minimum cost to get up and going. But I definitely feel like that's unbelievable. Only $5. And I know that, not all countries or nations around the world, $5 US may be still, a significant undertaking. And I get that. But that is the bare minimum to get you going. And it's totally sufficient. It's absolutely sufficient to get up and running from homemaker projects. Then you can rely on Hackster.io, the Adafruit blog, the SparkFun content. Where you go from there is kind of up to you. Certainly, if you can swing it, a $25 or a $35 Pi, or up into the 96 boards product lineup, which is again a little bit pricier, but you do get what you pay for. Then you can really start to learn from standard Debian, Fedora, Ubuntu installations. You can go through. There's tons of resources, even like documents like DigitalOcean's repository and guides. Once you've got the hardware in hand, you can go in any direction you like, really.
Right. Yeah, I also, another thing you had said was you can try out distros in a VirtualBox. That's
absolutely.
Really nice.
Yeah, from just tinkering and learning from an operating system perspective, you could actually get started before purchasing any specific hardware or devices with just, Linux distros are free to use. Some of them, of course, offer support services and other things, but the initial download and installation, they're free. That's how I got started, was using VirtualBox and trying out Fedora, probably like 1 or 2, and I know they're on like Fedora 30 or 31 now, so that ages me a bit, but like literally just download the image and run it in VirtualBox and start playing.
Yeah. And then how about the server administration things? How does someone start with that, or even know what to look for?
Yeah, so the way that I started to learn about that was actually very similarly. There are a handful of free server administration GUIs or control panels out there. And the thing about that is it's a point-and-click way to start to learn about the operations and control mechanisms of a server. So you can kind of see and understand what is being done as you make these changes from a point-and-click interface. You could then, if you're inquisitive, go and check underneath of that via command line or log files, what is the control panel actually doing? It's firing off a series of commands under the hood. Well, what was the command that run? Okay, what did that command do? What changed? What was altered? Do I need this control panel, or could I get rid of the control panel and just do it myself? Or the control panels are also good for just literally graphically showing you what a server is capable of. Right. DNS, email, web hosting, databases, firewalls, authentication mechanisms, all the other things and roles that a server can do. Fedora includes a nice one called Cockpit. which is a good one for, getting started with. There's control panels that will even start to dabble into virtualization and putting VMs onto your server from a graphical perspective. So there's all kinds of, ways to go about it.
Right. So someone would look up like server control panel and they'd be able to...
Yeah. I'm trying to think. Webmin is one of them. Drawing a blank, apologize. But yeah, they're out there.
Nice. Okay, yeah, I think that would probably be helpful for somebody trying to look into server, how to get started with servers. I had no idea.
Yeah.
So that's cool.
That's a great way to learn. Yeah.
Awesome. Well,
Great. That's basically all of our questions. Anything else you'd like to share with our viewers?
No, I think we've covered everything. I would say that, if you are an ARM enthusiast, you definitely want to join the ARM Discord that Robert and Carl run. So if you guys want to drop the link into the YouTube chat or in the comments after the video is posted, make sure we get that link in there so we can get some people joining up on the Discord server. You can find all of us in there. And like I said, the community is really your most powerful weapon in learning all of this.
Yeah. Carlos, our coworker, and Robert are having a conversation about how Carlos wipes his whole computer when he wants to try a new distro.
Which
and Robert's
can happen a lot.
Happens
sometimes.
a lot, yeah.
Yeah, you can do that. You can.
Oh,
if you have a spare machine.
And then Robert's like, why not Doob?
Yeah, you can do that.
Yeah.
Are they in there having a chat about it right now?
They're having a chat about it right now.
I'm trying not to multitask too much.
Yeah. But
get that Discord link dropped in for everyone to join. And I mean, otherwise, just, certainly if you have questions, tweet me at miniNodes.
Yeah, we'll definitely put your tweet, the Discord server, the blog post you mentioned, and miniNodes website in the description after the video, after the video's out. And thank you so much for being here.
Yeah, thank you.
Yeah, this was it was great talking and learning. I actually before I'd heard of miniNodes, but I didn't properly know what you were doing. So it was very interesting to read about it and then hear from you about it. Because it's just a part that I had not thought about, a part of...
Yeah, it's it's a whole different segment or niche within the ARM ecosystem. A lot of the ARM ecosystem revolves around, yes, of course, robotics, MCUs, self-driving, all the other technologies, the processors themselves, they cover such a wide range. Our little server niche and infrastructure niche, it's a cool community to be a part of.
Yeah, niches are fun because you always end up having interesting conversations that you wouldn't that you wouldn't have thought to have, very uncommon. So that's fun.
Cool.
Awesome.
Well, thanks for having me, you guys.
Yeah,
I totally appreciate it.
Yeah,
awesome.
Well, hopefully we'll see you soon.
Yeah.
Yeah.
All right, bye.
Bye.
Bye, guys. Bye, everybody.
Okay. So
awesome. Cool.
Back to us. Cool.
Very cool. Well, that was a fun combo.
Yeah. Very, very educational for me.
Oh, yeah. I mean, I don't know much about servers either, so...
The only thing I know is from, I've heard of DigitalOcean and Heroku servers.
Yeah, Heroku.
But other than that, not really, just hearsay, mostly,
yeah. No AWS is a thing.
Exactly.
Yeah.
But, yeah, it's cool. I guess I knew that servers are computers somewhere, but I don't know why I didn't think about that means the Raspberry Pi, we use that as a server all the time, right?
Yeah,
when we're doing any sort of web interface, we use that as a server, and that's kind of what he's doing, but in a more
essentially, but in a more distributed remote way.
Yeah, definitely an
cool.
Interesting
That's
idea.
Cool.
Yeah.
Awesome. So that was great. I guess announcements.
So Snips contest.
Yes.
It's still going on. quick thing. We are extending the deadline by one more week that I will announce today.
Yes,
on
we just did.
on
See?
the on the Voice AI hardware page. If you want and have a device, already have a project even, just submit it, because that's fun. And then besides that, we may be going to AIoT in December, most likely.
Yeah, most likely.
And so we'll be seeing you there.
Yeah.
And just keep up with our social media, and you'll be updated.
Oh, yeah. Oh, do you want to show a little bit of the robot
Oh,
pet,
yeah.
since you haven't shown it
So
on
the
one of our
Halloween
live streams?
project. Yeah, well, we're gonna actually do a live stream on this specifically. It'll be short, just going over the functionality of it, and just going
I'll
over the
hold it up.
functionality and how we did it, kind of. But this eye was coded with the ESP32 using Jay's code. Thank you, Jay.
Yes.
And then the Raspberry Pi is running ODAS, which is Open Embedded Audio System Sound Source Localization Tool. So it'll turn towards whoever's talking.
Yeah.
And it starts on boot. So theoretically, now that it is plugged into power,
Yes.
in a sec, it should the servo will start up, the service will start up, and it should be able to hear me and look at me. So this is actually Doris, the evil bowler hat from
Yes.
Meet the Robinsons.
Mm-hmm. Oh, it's on.
Okay, hey Doris, hello. Is it? Oh, there we
Yeah.
go. Okay, so
Let
turn
me, like-
it the other way.
Yeah.
Hey Doris, hello.
Well, it's already on that side.
Oh, it is? Okay.
Yeah,
Hey
that's why I was
Doris.
turning it.
Oh, hello. There we go.
Okay.
Hello, hey Doris. Okay, so we want to put it in the middle. Hello, 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 hello. Oh, yeah. Okay, so
Yeah,
as
there
you
we
can
go.
see, Doris reacts.
Here, maybe it will be better if I put it on.
Maybe. Hey Doris.
Yep.
So as you can see, that's how it kind of works. Hello. Hey Doris. But the thing is, it only does it in a 180-degree radius, which is why if I'm all the way back here, it probably won't hear me. We wore this on Halloween and walked around. We'll post some pictures about that. And it was kind of funny because every time we walked by a bar with loud music, the hat would just be like,
Oh, yeah.
staring at the you know,
The sound,
the
yeah.
sound, yeah. It was just kind of funny. But anyway, we'll finish off here. Thank you for joining.
Thanks,
and
guys.
We'll see you next time.
Yeah. Bye.
Bye.